Good afternoon to all. My name is Esdras, and I will present to you the paper Using Genetic Programming and Linear Regression for Academic Performance Analysis. My colleagues and I are from different Brazilian educational institutions. It's a pleasure for us to be here in AIED 2022. Okay, the problem. Um, in the Brazilian northeast, there is a city called Crato, and there is an institute for professional education. And like other educational institutions, it seeks to promote quality education. And quality education is one of the sustainable development goals of the United Nations, and understanding how to behave the academic performance of students is a big challenge yet. Quantitative assessment is still the most used means as a basic parameter to compute the student's academic performance in different subjects in the most diverse educational institutions in Brazil. But both quantitative and qualitative evaluation approaches are so relevant for monitoring the student's performance. But the qualitative aspects of evaluation can be a task that demands a lot of time and quantitative data used to be available in Avast. So it's fundamental to comprehend the success factors and other variables essential to students' performance. And we state a real problem of this educational institute. How to identify at-risk students in computer education previously. Because answering it, it's possible to forward these students to academic reinforcement, psychopedagogical support, or even social assistance. Okay, let's go to the solution. We propose to use an AI solution to predict these at-risk students. The essential idea is not novel and consists of using the initial grades of these students as a base to direct the tendency of your behavior during the academic year. At the Federal Institute of Ceará, more specifically, the evaluation process takes place every 2 months, allowing students to improve or maintain their performance in the course for over a year. So, the academic year is divided into 4 bimesters. At the end of each bimester, students receive a grade computed from a set of different kinds of assessments. Um, if this final grade is greater than a minimum limit, the student is considered able to attend the next curriculum phase. So, we use the data from the 2 first bimesters to train and test our AI solution. The purpose is to estimate who students may fail at the end of the academic year. The novelty of this solution resides in combining genetic programming and linear regression. Its name is GP4AR. Genetic programming has a background idea of evolutionary algorithms, But the most crucial difference between genetic programming and other evolutionary algorithms is the kind of individuals in its population. In genetic programming, each individual doesn't represent only a single solution of a given search space. Each individual represents a candidate model to tackle this search space. So, in GP4LR case, each individual is a potential linear regression capable of dealing with the prediction problem of at-risk students. Okay, let's watch a short demo video of GP4LR during its use by a Portuguese user. In this video, we set all the bases necessary for GP4LR training, test, and validation base. In this step, we set the parameters of the genetic program, like the mutation rate and the number of generations. At this moment, we inform the parameters of linear regression. In the end, we have a report presenting us with the best candidate and some significant statistical results include our residual analysis. And it's possible to save this report in PDF format. Okay, it's good. Um, okay, all right. The results. Um, we use three datasets to validate GP4LR from technical course on informatics integrated with high school. The first dataset relates to the subject, logic, and programming language. The second one to the topic, web development language 1. And the last one to all the subjects of the mentioned course for 2020 and 2021. Each dataset contains 110, 79, and 5,732 records, respectively. Well, we present here the evaluation of the prediction performance using the coefficient of determination, also called the I-squared metric. The metric assesses the quality of fitness concerning each linear regression model. In our paper, we describe these experiments details, include the values of all parameters used and other essential metrics adopted during this validation. Um, the model generated by GP4LR can explain 74% of the dataset run, and the GP4LR represented model can explain 82% of dataset 2, and the model generated by our solution also can explain 17 4% of dataset 3. Okay, acknowledgements. We thank all institutions that supported us to be here. Federal Institute of Ceará, IFC, Federal University of Jataí, UFJ, Federal University of Pernambuco, UFPE, and State University of Ceará, US. Don't hesitate to contact us. Thank you very much, and I am here for eventual questions.